greatest. There are here.
Good morning, good afternoon, one and all. First and foremost, I'd like to thank Department of Namchi Government College as well as Dr. C.P. Khatewan sir for providing us this platform as well as this opportunity for each and every BSc first sem students for this assignment. So myself, Janak Guru with roll number 19NS0093 BSc first semester. So I have been assigned the topic that is addition of velocity. So before studying the topic addition of velocity, we must know about the postulates of theory of relativity. T-H-E-O-R-Y, theory of R-E-L-A-T-I. We must know the postulates of theory of relativity about the constancy of speed of light. C equals to 3 into 10 to the power 8 meter per second. Well, it means to say that speed of light is same for every frame of reference respective to their relative motion. So, according to these postulates, theory of relativity, or due to these postulates, the concept of velocity addition theorem cannot be solved in our daily life. Why? Because when one frame moves with huge velocity relative to any other frame of reference, the concept of velocity addition theorem cannot be solved in our day-to-day life. In our daily life, we apply simple method for addition of velocity. So let us start with some example. So let us assume one car. So we consider one car that is moving with velocity 30 meter per second in this direction, and the driver who is driving this car threw one ball towards this direction, with velocity 10 meter per second, and this is a road where the driver is driving a car, and the observer who is observing this car, according to his frame of reference, he found the total velocity of ball to be 40 meter per second. So total velocity equal to velocity of car plus velocity of ball. We have velocity of car that is 30 meter per second plus, and velocity of ball that is 10 meter per second. So the total velocity we get is 40 meter per second. So actually this observer found that what he did is he added both the velocity, that is velocity of car 30 meter per second and velocity of ball that is 10 meter per second. The resultant velocity he get is 40 meter per second, which is true. So now to make the more concept clear, I'll provide you with the same next example. Suppose, let us consider or let us assume that it was a midnight. midnight, where there is no light, and we consider this as a headlight of a car, where the light is extracting or emitting from the headlight of a car. And we know that the speed of light is c, 3 into 10 to the power 8 meter per second. And the car moving with velocity v towards this direction. The observer who is observing this frame of reference found the speed of light to be c plus v. So, according to the Newtonian theory or theory of relativity, it must be c plus v, which is greater than the speed of light, which is not true. So, here our common sense notion is failed here. So, to make the concept clear, let us take the next example. Let us consider this, or let us assume this as a supercar, that is advanced technology car, moving with velocity c by 2, and this is the headlight of a car. We know that the speed of light is c. So, according to this person, or according to his frame of reference, the speed of light must be c plus c by 2. So, by solving it, we will get 3 c by 2, which is not true, because we know that speed of light cannot proceed with speed greater than c. So, again here our common sense notion is failed here. So, to add the speed, if the frame of reference moves with huge velocity, we will study in this topic, that is addition of velocity, more clearly. So, in this topic, addition of velocity, we will going to derive expression. If one frame moves with huge velocity, how to add the speed. So, let us consider two frame of reference S and S prime frame. S frame and S prime frame. X coordinate, Y and Z. X prime, Y prime, Z prime, and X, Y, Z. So whatever the assumption we have taken here, we will going to write here. Let us consider, let us consider two frame of reference S and S prime, where S prime is moving towards positive x direction relative to S frame with velocity v. So we have considered here two frames, that is S and S prime frame, and this S prime frame is moving with velocity v towards positive x direction relative to S prime frame, S frame. velocity v, which is moving with velocity v. And now let us consider one particle in S prime frame. Let us consider one particle in S prime frame, which is moving relative to both the frame of FERE and CE reference. And here we have considered one particle in S prime frame which is moving relative to both the frame, that is S frame and S prime and S frame. Now this particle have two velocities v and v prime. These particles have two velocity v and v prime. According to S and S prime frame. For S frame it has velocity v, and for S prime frame it has velocity v prime. Let these particles move freely in 3 dimensions. Let this particle move freely in 3 dimensions. The particles has 3 velocity components. And this particle has 3 velocity components. The velocity components in this S prime frame is, considering here a particle, and the velocity component in X prime frame is V prime Y, V prime X and V prime Z. The particle has 3 velocity components, that is, for S prime frame there V prime X, V prime Y and V prime Z. And also the velocity components for S frame is this is a particle considering for S frame, and the velocity components are Vx, Vy and Vz. Vx, Vy and Vz. So these all are the assumptions that we have taken for this topic, addition of velocities. We have considered here two frame, S and S prime frame, and we have considered here one particle that is moving freely in 3 dimensions, and this particle is moving relative to both the frame, for to S prime frame and also for S frame. So now for derivative part, I am going to rub this assumption. So now for S frame, F-R-A-M-E frame. For S frame, the rate of change of x with respect to time is Vx equals to dx by dt, and Vy equals to dy by dt, and Vz equals to dz by dt. And this is the definition of velocity for S prime frame. The rate of change of x dash with respect to time is V dash x equals to dx dash by dt dash, Vy dash equal to dy dash by dt dash, and Vz dash equal to dz dash by dtz. So this is the definition of velocity. And now using inverse Lorentz transformation equation. Now by using INVERS, inverse Lorentz TRANSFORMATION transformation equation. Now by using Lorentz transformation equation, x equals to x prime plus v t prime by root over 1 minus v square by c square, and y equals to y prime, and z equals to z prime. So, and last one, t equals to t prime plus v x prime by c square root over 1 minus v square by c square. So we have written here all the 4 Lorentz transformation equation, that is x equal to x prime plus vt prime by root over 1 minus v square by c square, and y equals to y prime, and z equals to z prime, and t equals to t prime plus vx prime by c square divided by root over 1 minus v square by c square. So Hence, on differentiating differentiating all the four equation, we get, now we have to differentiate all these four equation, we get on differentiating x, we get dx equals to dx prime plus v dt prime, and here this v is constant, so divided by root over 1 minus v square by c square, and this everything under the root is constant. So on differentiating on y, we get y equals to dy equals to dy prime, and on differentiating z, we get dz equals to dz prime. On differentiating t, we get dt equals to dt prime plus v, this v is constant, dx prime by c square divided by root over 1 minus v square by c square. So we have differentiated here all the four Lorentz inverse equation. Now we have to find the value of Vx. Vx equals to, what is Vx? Vx equals to dx by dt. So we have got dx. Vx equal to dx by dt from here, and on putting the value of dx equal to dx prime plus v dt prime divided by root over 1 minus v square by c square into dt one minus v square by c square divided by dt prime plus v dx prime by c square, and we can cut as there is same value. So now again we have to manipulate it on differentiating, not on differentiating, sorry, on dividing numerator ERA, numerator and denominator by dt prime. So we have to divide here numerator and denominator by dt prime. Vx equals to dx prime by dt prime plus v dt prime by dt prime by dt prime by dt prime plus v dx prime by root by c square dx by dt prime. So Vx equals to dx prime by dt prime. So we can put the value dx by dt prime. Dx by dt prime equals to vx prime. So we can write dx by dt prime as vx prime plus v b, and dt prime and dt prime get cancelled out, and dt prime and dt prime also get cancelled out. So by 1 plus and b by c square, b by c square, dx by dt prime we can also write dx by dt prime we can also write vx prime, vx prime. And here we get the value of vx. This is how to add the addition of this, how to add the velocity in x direction. Now similarly we have to find vy and vz. For finding vy and vz, vy equals to dy by dt. Here, as we have written earlier, vy equals to dy by dt, dy by dt. So we have to put the value of dy. Vy equals to dy prime, dy prime, and dt equals to, putting value of dt from here, dt prime plus v dx prime by c square root over 1 minus v square by c square. Now again what we have to do here is that we have to multiply numerator and denominator by dt prime. On dividing numerator and denominator by dt prime, we get vy equals to dy prime by dt prime, and this comes out root over 1 minus v square by c square divided by dt prime by dt prime, and plus v by c square dx prime by dt prime. So by one manipulation we'll get vy equals to dy by dt prime. We can also write dy by dt prime as vy prime, and 1 minus v square by c square divided by dt prime and dt prime get cancelled out each other. 1 plus v by c square, and dx by dt prime is dx by dt prime equal to vx prime, So the final formula of vy prime, we have get vy equals to vy prime into root over 1 minus b square by c square divided by 1 plus v by c square into vx prime. So similarly, now for vz prime, for vz equals to dz by dt. So putting the value of dz and dt will get vz equal to, so we have to write the value of dz equal to dz prime, dz prime divided by so we have to write the value of dt equal to dt prime plus v by c square dx prime root over 1 minus v square by c square. So now again here we have to divide the numerator and denominator by dt prime. On dividing NUMERA numerator and denominator by dt prime, we get Vz equal to and dz prime by dt prime into 1 minus b square by c square and divided by dt prime plus v by c square dx prime by dt prime. So here we have divided numerator and denominator by dt prime. Hence, and on manipulation we'll get Vz equals to dz by dt, we can also write dz prime by dt prime, we can also write Vz prime as we have written earlier, Vz prime into root over 1 minus v square by c square divided by dt prime and dt prime get cancelled out each other and we'll get 1 plus b by c square dx prime and dt prime we can also write from the equation vx prime bx prime. So we have got the final value of vz also. So we have find vx, vy and vz. Here vx equals to vx prime plus v1 divided by 1 plus v by c square into vx prime, and we have got vy equals to vy prime into 1 minus v square by c square divided by 1 plus v by c square into vx prime, and the vz equals to vz prime into 1 minus v square by c square divided by 1 plus v by c square into vx prime. So here we get different value of vz and vy as compared to vx, because this vx is moving because here s frame is moving along vx x direction. That's why we have get different value of vx as compared to vz and vy. So we have completed the derivative part of the addition of velocity. Now we are going to solve the sum question on the basis of this topic. So I am going to rub this. So here we have derived the three equations. So I am going to write here addition of velocity for along x-axis equals to Vx equals to Vx prime plus V root over 1 plus d by c square Vx. Square, and along y axis Vy equals to dy prime over 1 minus b square by c square by 1 plus d by c square Vx prime. Here Vx prime. Along vz direction, Vz equals to Vg z prime root over 1 minus v square by c square divided by 1 plus v by c square Vx prime. So this is the three equations we have derived earlier in the topic addition of velocity. Now we are going to do some numerical part according to this formula. So let us assume two frame, S and S prime frame. Assuming two frame, this is S frame, and this is y coordinate, x coordinate, and z coordinate, and origin O, and this is next frame. This is S prime frame, x prime, y prime, and z prime. This is S prime frame. So here we have assumed two frame, S and S prime frame. So let this frame move with velocity c by 2 relative to this frame S. This S frame is moving with velocity c by 2. This S frame is moving with velocity c by 2 relative to this S frame. And also let us consider one particle in this frame, S prime frame. So we are considering one particle in this S prime frame. So here we have considered one particle, and let this particle also move with velocity c by 2 relative to this S prime frame, c by 2, v and v. So let us also include one observer in this frame. So now this S prime frame is moving with velocity c by 2 relative to this S frame, and the particle in this S prime frame is moving with velocity c by 2 relative to this S prime frame. So the observer who is observing this frame supposed to find that speed of light must be c, because usually what we do is half and half is 1. So the speed of light must be c, because c by 2 and c by 2 usually it must be c. So now we can use the formula for adding velocity addition theorem along Vx direction, because as it is shown that S prime frame is moving along Vx direction, because it is moving along Vx direction. So we can easily put the formula this Vx1. Or if we do not agree and want to take general formula, So we can take v, y and vz, but it is already said in example that this s prime frame is moving along vx direction. So now using the formula vx, one solution, velocity for velocity moving relative relative to s frame is velocity moving relative to s frame is v by so velocity of s prime frame, velocity of s prime frame is c by 2, v equal to c by 2. This velocity of s prime frame is c by 2 relative to relative to s frame, as I have said earlier. And velocity, where velocity of particle, 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 moving moving in s prime frame is also v equal to c by 2 relative to relative to s prime frame, because here the particle is moving in s prime frame and it is moving with velocity c by 2. So now using the formula along vx direction, so writing the formula vx equals to vx prime plus v1 plus v by c square vx prime. So vx equals to, and particle is moving in v, and this particle is moving in s prime frame, so this one must be vx prime, and vx equal to vx prime, so particle velocity is c by 2, so vx prime we have to write c by 2, plus what is v? V is c by 2, velocity of s prime frame, velocity of s prime frame is c by 2, and velocity of this particle is also c by 2, so v is c by 2, and divided by 1 plus v is c by 2, and vx prime is also into c by 2 and by c square, 1 by c square. So c into c is c square, so cancelling c and c square, and by doing LCM, vx equals to LCM 2 plus 2 is LCM 2, there is 2c, and by 1 plus what is that? 1 by 2 to the 2 into 2 is 4. So we can cut here 2 by 2 get cancelled out, and so I write here vx equals to c 1 plus 1 by 4. So here we have to do LCM, vx equals to c, so by doing LCM 4 by 5, so this comes up and we are cross multiply, vx equal to 4c by 5. So this is the resultant. This is the velocity observed by this observer. So here in theory of relativity, in theory of relativity, we found that half plus half is not 1. Half plus half is not 1 because half plus half is, we found it 4 by 5. So it, according to this observer, the S prime frame is moving with velocity c by 2, and the particle is also moving with velocity c by 2. It must be c according to this observer, but it is not like that in this theory of relativity. So in theory of relativity, half plus half is not 1, it is 4 by 5, as we have derived here. So by rubbing, I am going to rub this and do the next example. So for the next question also, we are assuming the same two frame as an S prime frame. So let this S prime frame move with velocity c. Let this S prime frame move with velocity c relative to this S frame, and let this particle move with velocity v. Velocity c. So here we have assumed two frames as an S prime frame, and S prime frame is moving with velocity c, and the particle in S prime frame is moving with c. So it is moving, as we can see here, it is moving along x direction. So now using the formula Vx, Vx equals to Vx prime, Vx equals to c. Solution Vx equals to c. So and Vx prime equal to velocity of particle equal to also c. So we have formula Vx equals to Vx prime plus v divided by 1 plus v by c square Vx prime. So Vx equals to Vx prime. So Vx prime, what we have? We have c, velocity of particle, that is c plus, and velocity of this frame, S frame, is also c. So 1 plus v, here v is c, and by c square, and Vx prime is also c into c. So Vx equal to c plus c is 2c, and 1 we have 1, and c into c is c square by c square. So you see e square and c square get cancelled out, c and c square get cancelled out. So we have 1 plus 1 plus 1. Vx equals to 2c. 1 plus 1 is 2. 2 and 2 get cancelled out. So Vx, we get Vx equals to c. So what we did here is we have considered the two frame S frame and S prime frame, and this S prime frame is moving with velocity c, and the particle in S prime frame is also moving with velocity c. The observer here, who is observing the velocity of light, must be c. So by using the formula for addition of velocity in x direction, we got Vx equal to c. So what we conclude from here from this numerical is that about the constancy of light. So when a particle moves with the velocity speed of light, it does not go greater than speed of light, as we have learned in the earlier section in the postulates of theory of relativity about the constancy of speed of light. So whatever the speed the particle is moving here is observed by the observer in this frame. So he also sees this frame with the speed of light, that is c, and the particle moving here with the speed, that is also c. So we have done the two numerical. How to do the numerical we have done. So I hope you understand it, and also we found Vx equal to c. We found the Vx equal to c, and this is the constancy of light as mentioned in the postulate of theory of relativity. So this is the beauty or important of theory of relativity. So thank you. Stay safe and stay healthy.